Today we're going to talk about net ionic equations. Net ionic equations are just another way of dealing with the chemical equation. The goal is to eliminate spectator ions and to solve for the solid. How do we do that? We do that by separating the compounds into ions and canceling like terms. Let's look at an example. Here we have a chemical equation, and as you notice, it includes the state in which the compounds are in, whether it's aqueous or a solid. Our first step is to split each compound into its individual ions, which will include the ion's charge and the state in which it is in. Let's start with our first compound. We're going to be splitting this compound into two ions because we have Pb and nitrate. So our first one is Pb and our second one is nitrate. Now we need to include the charge and the state. So we know that these both are aqueous. And Pb, since this came from the charge, remember the crisscrossing situation, so we're going to put this one back up here, 2 plus. And this one, we know nitrate is a negative. One thing we need to remember though is whatever is this subscript outside the parentheses, we need to put it in front of that compound. Now we'll move on to our next one. We have hydrogen and sulfate. Our charges crisscrossing the subscripts, which outside the parentheses would just be 1. That's why there's no parentheses there. Or you could look at the periodic table. So we put a 1 up here, which is just plus, and a 2 minus over here. Remember to include the state in which the ion is in. Now moving on to this side of the chemical equation. Since this one is a solid, we don't split it. Don't split solids. Okay, so let's just write this one down here as is. Oops, that's not C. Here we go. And that is a solid. Okay, we'll do this very last compound. Once again, we have two ions. We have hydrogen and nitrate. We know nitrate has a charge of -1 and hydrogen has a charge of +1. Since there's a 2 in the coefficient, we need to bring that down here as well and include there the state in which the ion is in, aqueous. Oops. Okay, so those two got a little close, but they are separate. Now we need to add these all together as if they are in a chemical equation. So add all of our symbols, plus all of these equals these over here. There's a little plus sign between there. Now for the fun part, canceling the like terms. We see that we have nitrate over here and over here. We're going to cross those out. We also see that we have hydrogen on both sides. We're going to cross those out. And we are left with Pb and sulfate and our solid. So we're going to write those in a new equation, which will be our net ionic equation. Okay, let's write it out. We have Pb 2 plus aqueous plus SO4 2 minus, oops, that one needs to go up there, aqueous. And that makes our solid, which is PbSO4 solid.